Hello and welcome to the Thinking Out Loud podcast. In this episode, I have a conversation with the data scientist Phani Srikanth, who is presently working at Reliance Jio. He won many data science competitions and stands in the top 1% on Kaggle's leaderboard. I think this conversation will be helpful for both listeners who are interested in data science and also who want to take up and have a career in data science. One thing that I found striking during this conversation is Phani's commitment to work consistently and build his skills in the field of data science. He works 2 hours every day on data science even after doing a full-time job, and he spends much more time during the weekends. And I think that is something very important that everyone should do if they really want to build skills in a specific field. So on the podcast, I want to commit to doing something very interesting. So for the next 1 week, I publicly commit that I will work for 2 hours every day after 9 pm, maybe around 9 pm to 11 pm, to build my critical thinking skills. Now listeners, if you are someone who can spend 2 hours more in the evening, instead of watching TV, you can spend 2 hours to improve a specific skill set of yours. I think this is a good time that you commit to do that for the next 1 week and see how that works out. And now I present to you Phani Srikanth. Hi Phani, it's great to have you on the podcast.
Hi Surya, it's nice to be here talking to you.
Yeah, so I just want to give our listeners a little background about how this conversation came up. So I think we never met before. This is the first time we are talking real time. We just exchanged a few messages before.
Yeah, that is true. It's ironical that we have never met in the campus where we studied for 4 long years, but we have kind of gotten in touch after I left the campus and online. Yeah, I think internet is helping.
Yeah. But we were together on campus for only 1 year, right? You were 3 years senior to me. So
that is true. Yeah, that is true.
So for the listeners, I used to see Phani's posts occasionally talking about data science, saying that he won so-and-so competition. And I got really excited by that. I registered for a few data science competitions, but I never really worked seriously on them. And when I saw Phani a few weeks ago posting that he won a data science competition and he got a cash prize of 3.5 lakhs, is that right?
Yes, 3.5 lakhs.
Yeah. So I was really excited and I really wanted to have a conversation with Phani. So I reached out to him saying, I want to have you on my podcast, and he was very generous and he said yes right away. And that is how we are having the conversation.
Yeah, that is true. To give the listeners a little insight into how I've come to know about Surya. So I've never met him in college before. However, after moving out of college and while I used to work at a corporate, I've come across my juniors liking a couple of Surya's posts on Facebook, and that's when I came to know that a junior in my college is working on some really, really interesting engineering projects, which are pretty rare during my 4-year stint at the college. And slowly I've come across a lot of his motivational posts and a lot of effort going into teaching students and motivating them to increase their productivity and a lot of other stuff. And that's when I realized that, okay, here's a chap who's really interested in building skill sets that are generic and that help him across multiple domains. And I thought, when he asked me about joining him on his podcast, so I thought, okay, let us probably give it a shot and see how it goes. So yeah, that's how I'm here today.
Right. So for the listeners, can you just introduce yourself for people who don't know you?
Yeah, sure. So I am Phani Srikanth and I currently work at Reliance Jio Money. I've graduated from NIT Warangal in 2012 and I've worked with multiple product-based firms before joining Jio. I currently specialize in building data science solutions for mid-level startups and large corporates wherein there's good amount of data, and my core expertise lies in building accurate machine learning models and moving the metrics needle in the right direction.
So as far as I know, you haven't started off with data science when you were on campus, right? When you were in NIT Warangal in 2012, that's when you graduated, right?
Yeah, that is true. I have graduated in electrical engineering out of campus.
Yeah, and you had no data science experience at the time you graduated.
Absolutely zero. I almost hated programming too. Yeah.
Okay, then what makes you so passionate about data science? Since when did you have this inclination towards data science?
I have been having a I've been comfortable with numbers since quite a young age, and at one point of time in college, I had this notorious habit of remembering almost 100 telephone numbers of my peers who used to work with me. So at the same time, luckily I got a campus placement at Oracle Financial Services, and that was a place where I have been introduced to building software products, wherein I've learned the essentials of it. And 2 years into Oracle, I realized that software engineering might not be my cup of tea. And I realized that I can leverage my interest in numbers and mathematics and probably augment it with my skills in programming that I've learned at Oracle. And as a fact, data was also increasing, and the internet age and smartphones age and the Facebook has been very coming up drastically. So during this point of time, I realized that data is here to stay. Data is here only to increase in size, and I realized that this data can be used as a resource to find trends and patterns in customer behavior, and this can be leveraged by businesses and can be effectively put to use for better business performance. And at the same time, in data science, I am very interested in predictive modeling and machine learning because of the fact that just using historical data and some simple algorithms, we have the potential and the capability to predict and forecast future phenomena, be it sales, be it churn, or be it fraud, which is of immense value to any organization. In fact, if they know what is going to happen tomorrow, they can take decisions based on that. So that is of immense value to any organization, and that interested me to go into this field.
So, what is predictive learning? Is it just predicting future based on data, or?
Yeah, typically what happens in predictive modeling is the fact that you have historical data of how customers have been behaving, and let's take a very simple use case. So let's say I have a subscription-driven magazine business, and I know that a lot of people, X number of people are subscribing to my business, and Y number of people are not repetitive customers, or let's say they have unsubscribed in the last in couple of months. Now I know that these people have been there on my platform from this demographics in this particular age buckets, and who have been exhibiting a particular interest in a particular features, and these guys have churned. They have not resubscribed to my magazine. Now using this historical data, I can also identify patterns and trends which will help me forecast which customer would potentially unsubscribe in the next month or the next couple of months, which will help me to roll out an offer or a coupon or a discount to that particular customer to keep him re-engaged to my platform. So this is a very small example, and this particular way of experimentation and going about modeling user behavior can be generalized across multiple industries and multiple business lines. Yeah.
Interesting. So I just want to go back to when you were young. So you used to remember numbers. Did you use specific memory techniques, or do you just remember them?
I think I just remember them. So I'm still not sure what kind of memory I had during college, but I just used to remember numbers. I've been comfortable with with numbers since quite some time. So I think they have come naturally to me. So I was never afraid of numbers. So I think that was one main reason why I have decided to move into data science. So, and to be very honest, whenever I work in today's world, so whenever I work on my laptop, I almost have 80% of my laptop covered with numbers all throughout the place, and I still can make some sense out of it. So
you have random numbers, or?
No. So the data that we deal with is essentially customer data or merchants data or whatever it is, and people have an inherent pattern in which they actually go about using systems. So if I'm let's say using Facebook as a platform, so there is a particular behavior in which I use Facebook. So there are broad patterns and there are micro patterns in every business or every particular product that people use. So when we analyze data, we try to extract those broad patterns, or we try to come up with those micro patterns that certain segment of users are behaving, and convey these particular insights to the stakeholders so that they can take better decisions on how they would want to personalize or deal with those set of customers.
Okay. I when you talk about Facebook, I remember this example. So I was searching for a product on Amazon, and when I went back to Facebook, Facebook started putting up a lot of ads on that. I found that creepy. And
Yeah.
I wasn't very happy about that. I mean, how does it know what I did on Amazon? How does that work?
Haha, so yeah, so this is one very famous example that I used to tell to a lot of my friends. So let's say I go to Flipkart, I browse for a shoe, I don't buy it, I come back, I open Facebook, immediately the Flipkart shoe comes up on my Facebook. So it's very, very common, and in fact it is a very, very simple technique. So what these big internet web scale firms do is they store cookies on your browser, which actually track the user across multiple platforms. This is one way that Facebook actually knows what you're browsing. At the same time, what also happens is Facebook, Google, InMobi, and many other ad exchanges also have a digital advertising platform, wherein let's say I come to Flipkart, and the Flipkart has, to give you some more insight into how it exactly works, Flipkart actually creates a particular ID for me. Let's say Flipkart has Google Analytics, and Google Analytics helps arrive at a particular ID and shares this with Flipkart. And let's say I don't buy the item. So the digital marketing team at Flipkart or Amazon, what they do is they again take this particular ID and they give it to Google, saying whenever this particular user searches for anything on Google, or whenever this particular guy comes on Facebook, for this particular user with this GA Google Analytics ID, float this particular ad on the platform. So that is how they do retargeting. So this is called classic retargeting, in fact.
Okay, so when I create an account on Amazon, in the terms and conditions, do they say that they're gonna use our data for this purpose? Do they mention that in the terms and conditions?
Well, what happens is you don't even technically have to register or sign in at this platform. The mere fact that you are using the website itself, they come up with a unique user ID for you, despite you not registering on the platform. So it is not intrusive in any particular way because of the fact that they are not using any sensitive information here. So that is fine. Yeah.
Okay. Um, so before we talk more about data science, I just want to know what are other things you're passionate about other than data science?
Well, apart from spending a lot of time on data science on a day-to-day basis, I am also very interested in music. Classical rock music being my latest new interest that I've been hanging on to. At the same time, I've been playing a lot of very interesting board games of late, thanks to my awesome flatmate who gets all these amazing board games from God knows where. And I'm also a very ardent follower of many sports. Cricket, my favorite. So that has been my pastime, favorite things apart from data science, and I'm also looking forward to add a couple of very, very new things in 2017 so that I could probably diversify in some ways. Yeah.
Oh wow, things like what?
Uh, Probably running is on my list. So probably I would want to start with one and then probably add one more after 3 or 4 months once I get into the groove.
Oh, interesting. So you mentioned the board games, right? Are they a lot of fun?
Yeah, absolutely. In fact, so I've never realized that board games are a lot of fun. So I used to play a set of very small number of board games, but this guy, my flatmate, has a lot of very, very interesting ones. So yeah, so I've been playing almost 10, 15 of them, which are really, really new to me, and I've been enjoying it ever since.
Oh wow, can you tell me a couple of board games? I'm really excited.
Well, so I think my favorite game that we currently have played in the last 3, 4 weeks is Catan, which essentially is a strategy game wherein it is like an AoE equivalent. So if you have played Age of Empires, then you pretty much know that you have to construct colonies, you have to construct roads, cities, and settlements by using resources. So you have to optimize resources such as grass, bricks, stores, and all of those, and build colonies and occupy the largest amount of colony in a given space of in a given board space. So it is about strategizing what do you want, when do you want what, and trading with other people and all of that. So Catan is a very, very interesting board game. It's called Settlers of Catan. So that's a pretty interesting one. At the same time, another game very interesting that I've played was it's called Risk, wherein we it's a board game with 5 to 6 players, wherein people again have to occupy a lot of countries. So each player has 13 territories that he initially starts with, and then the objective of the game is to expand and colonize across as many countries as possible. So that is one. At the same time, the other interesting game is called Hanabi, wherein it's called a cooperative board game. So I've never played cooperative board games before, but a cooperative board game is a game where all of us, participants are playing against the board. So if three of us are playing, we don't play against each other. All three of us play against the board. So this is a very interesting thing because I've never played board games such as those. So yeah, so I've been getting introduced to really nice games in the last 2-3 months.
Oh, wow.
And this also helps me take my time off from the usual data science work, probably refresh, do something very, very different and regroup and go back to data science, yeah, when it matters. So yeah.
Interesting. I think this is a good way to spend time with friends. In general, I don't really know what fun things we can do when I meet friends. We go to malls, we watch movies, and that doesn't really seem like a lot of fun to me. This is something I guess we should try.
Yeah, you should probably give it a shot. You might most likely like it.
Okay. So let's get back to data science. For someone who doesn't know anything about data science, someone who's listening to the word data science for the first time, how would you say what data science is?
Well, data science is about making sense out of data. So that is the simplest way I could put it. Or it is about identifying structural patterns in data and identifying the signal, identifying the noise in data, which essentially helps you understand behavior of users or anybody of the whole system, and use these insights to take an action that helps organizations or anything of that sort. So let's a simple example could be let's say a banking system. In a banking system, there are a lot of people who are non-fraudulent users who follow the regular structure. At the same time, there are also fraudulent users who try to game the system and try to do anti-money laundering and all of those. So ultimately, what banking systems would want to do is the fact that they would want to identify those people who are trying to game the system and ban those users from using the platform. So it is about finding those micro patterns and how people are trying to trick the system and getting rid of them. So that is where your historic data that you've been capturing helps you in identifying the trends in which people typically try to gain a system. So there are people come up with a lot of strategies in doing that. At the same time, people exhibit common patterns in how they behave with the system. That helps in giving you broad patterns that you can see. So as data scientists, what we do is we our daily workflows include and involve working with data extensively. So sometimes we do not even have a problem statement. Our problem statement just says analyze this data and come up with any insights. That's it, nothing. So we exactly do not know what we're looking at, but the goal is to find something that is very interesting, that is just hiding in plain sight. So it involves certain amount of curiosity in finding something. It also involves certain amount of skepticism, and it's also fun. Finding a needle in a haystack is sometimes fun, and it's fun for us a lot of times. So yeah.
So, in the specific case of banking, what is your input and what is your output for the algorithm?
So let's say, to take a very simple use case, let's say you have a set of transactions. So in transaction level data, you have the time at which the transaction was done, the ID of the guy who has done the transaction, and the type of transaction, whether it is a debit or a credit, and the amount of transaction. So a very, very popular anti-money laundering technique or a fraud detection technique is the fact that so I've come across this particular anti-money laundering case very recently, in fact, in a particular hackathon, so which I would want to share with you. So one of the very popular insights that we found through the data was that anti-money laundering people who do this typically would want to swindle funds from one country and route it through exchanges from different country and ultimately create it in a different country. So what they would ideally do is, if I had to swindle around $1 million, I wouldn't send all the $1 million at a time. What I would do is I would do a very large number of very small debits. So I would probably send it to an exchange a sum of $100 repetitively over a course of time. So I make very large number of small debits and do one large credit. So if you look at the transaction trail of that particular customer, you see that he has actually done around 30 to 40 debits, and then it's very small debits and one large credit that accounts to the whole sum of very small debits. So if you look at the transactions and if you look at it at the customer level through time, only then will you figure out that this particular customer is actually behaving in a very, very different way than how you or I would actually transact in a very normal situation. So this is where we do not exactly know what we're trying to find, because we do not know how they would do it. So it's also sometimes about just diving into the data and seeing what anomalies can you find. So we do a lot of plotting. We take the data, we plot it, we do bar plots, we do histograms and all of those, and see wherever statistically something doesn't make sense, and try to find anomalies and thus zero down on them, try to see if the pattern has reoccurred or resurfaced anywhere with other customers, and generalize it and make an insight out of it and communicate it to the stakeholders.
Very interesting. So what is the future of data science? Is the demand increasing or decreasing? I think data science came up very recently, right?
Well, that is true, but at the same time, data science has been prevalent in large-scale internet firms like Google, Facebook, LinkedIn, Netflix since quite a long time. Also, remember, the data science revolution has started from Netflix prize that Netflix actually came up with around 10 years ago. So it is not very new to the internet firms, because they have been getting a lot of data and they wanted to make sense out of it and have been doing it ever since. But every particular new way of solving problems takes a lot of time to be commoditized. So it is only very recently that many different industries such as manufacturing industry or supply chain industry or retail industry have caught on to this particular phenomenon and are using it increasingly every day. So at the same time, you also see that smartphones generate a lot of data every day, and we've just begun on the data juggernaut. So the amount of data collected every day is only increasing. So going forward, what the industry needs is data scientists who can skim through a lot of data. So by a lot, I mean terabytes, in fact, and still be able to find signal amidst a lot of noise in the data and try to make some sense out of it. So data science has just begun. It is here to stay. The demand is very high. So
Oh, wow. So when I posted on Facebook that I'm going to have a conversation with you, Ramesh really wanted to know this. So he asked, data science sometimes consists of automating jobs that are typically done manually. Can the complete job of data science engineer be automated?
The answer is yes and no. Because there are certain sections of data science that can be automated, while there are a whole lot of other bunch of sections which need domain expertise and human intervention. So I wouldn't say it can totally be automated, because there is the human element in it, because ultimately people who run the business, know exactly how the business operates, and they can give in their expertise in giving the models the right kind of input so that you get the right kind of output. And computers are still lame as long as the fact that you do not give them data. Yeah, so the computers are still lame as long as we explicitly program what to do. But with data, computers can get smart and can generalize across new data points that they see. So it is at this part that the human intervention is required, and we feed in the right kind of data, and then the computers can also make smart decisions around what is right and what is wrong. So some parts can be automated, but ultimately data science is science, so the human element is not going away anytime soon.
So let's start talking about competitions, the things that you win very often. What is a data science competition?
So typically data science competitions are about modeling a particular phenomenon using historical data and using this particular model that we have built to predict and forecast behavior on future data. So competitors are typically given a train set, which is historical data, with an observed phenomenon called the target variable. So think of it as let's say you have x1, x2, x3 as three inputs, and you have y as a particular output. So whenever you have x1 and x2 and x3 in your input, you have y as an output. So think of y as a function of x1, x2, x3. So in purely mathematical terms, y is equals to f of x1, x2, x3. The job of machine learning is to find the f, as simple as that. So the historical data is x1, x2, x3. The observed phenomenon is y, which is a target variable. Now what we do is we also get a test set which is in future, and we are asked to predict the target for this particular test set. So what we do is we build machine learning models by which we compute the f, and we use the f on the new x1, x2, x3 that we get, and we predict the new y, and the competition organizers match the y that we have predicted with the actual y that they have, and they compute the accuracy of our prediction. So the team with the highest accuracy on the test set typically wins the challenge, and problems typically range from 1 to 2 MB of data to around 50 to 100 GB of data, and models that we typically build are sometimes over in just hours, but sometimes they also takes days and weeks to run on laptops. Yeah, so
Okay, so the input data is generally numbers, or is it also images, or what other kinds of inputs can you have?
yeah, so typically it's about numbers. So let's say one of the variable could be an age, it's a number, one of it could be a height or a weight, they're numbers. It can also be the demographics, a state or a country, or something else. So they could also be categorical, so that could be one. At the same time, they can also be images, because ultimately the image recognition problem is also being currently solved, wherein the input is totally images and you're asked to predict who this person is. Even that is, Facebook is currently doing that. Whenever you upload a photo, it is immediately telling you, do you want to tag Surya or do you want to tag Phani here? So it is essentially running a machine learning algorithm predicting who the guy is. So the input could be image, the input could be numbers, the input could be categorical, the input could also be text. Remember, Google Translate currently does advanced deep learning models, and whenever you give a sentence, it tries to translate into a different language. So there, the input is a text sentence, and the output is also a text sentence in a different language. So the input could be anything, in fact. But typically, most of the times, our inputs are typically numbers and categorical variables, not image and text.
Okay. So, how many competitions have you won until now?
I've won around 4 competitions. Yeah, so
And this is at the same time when you're doing a full-time job, is it?
that is true. Yeah.
How do you make time?
Well, I usually spend a couple of hours every day to work on these competitions, and spend a good amount of time on the weekends to work on very interesting data sets and problems, and learn anything new on the way. So, working on different problems and working on different data sets help us in looking at the data very differently, because every data set is unique. Just as how every fingerprint is unique, every data set is unique for us.
Can you give examples of a few data sets?
Well, some of the data sets that I've worked with were transactional data in banking systems, also for fraud detection. They could also be sales data. So we know that in a particular store A, in a particular city, an item A was sold, the number of sales were around 10, let's say. And we have a lot of data of many particular stores, of many different items and many different sale values on many different days. And one of the goal is to predict the future sale for a particular item in a particular store, so the store manager can effectively manage inventory in the store. And let's say there are also items that get stale, that has low shelf life. He can better plan his inventory so that the wastage is low. So that is one data set that I've worked with. At the same time, another dataset is the click dataset, the ad-related dataset, wherein the search engines such as Google or Facebook, whenever they float an ad, they would also want to predict the probability that a user will click an ad when I show him a particular ad. So, let's say 10 companies have bidded to show an ad to a particular user. Now, Facebook determines which ad to show to the user so that the user has a higher probability of clicking it. So therein we had the ad ID, the ad related metadata, customer ID, customer related metadata, and the target being clicked or non-clicked. So this problem almost had around 40 million rows for around 7 days of data. So in 1 week they actually had around 40 million rows, and as we speak I think they would have actually got 100 MB more
Okay.
in just the last 1 minute. So and they predict, and yeah, that is pretty interesting to work with. So I've worked with various kinds of data sets. So and there's always something new to learn from every data set.
So, is there a secret to win these competitions? Is there one kind of algorithm that you know and no one else knows that you use to get the best result?
What happens is, due to the nature of the competition setup, what happens is accuracy on the test set is given higher weightage over interpretability of the models. And this is one reason why participants typically tend to use complex algorithms which push the accuracy. So typically what we use are the algorithms that are typical winners in many Kaggle competitions are gradient boosting algorithms, neural networks, factorization machines, and all of those. But having said that, there have been competitions and data sets where simple algorithms such as averages, linear models, nearest neighbor models, time series models just outperformed every other complex algorithm. So as they say, there is no free lunch. There is no one algorithm that beats everything on every data set, and that is the reason we have machine learning. If there was one master algorithm, then the f in y equal to f of x1 to xn would have already been found, and there would be no machine learning in that case. So the fun is to have f very differently in every problem. So typically we use these algorithms, but there are also a few tricks that you keep learning as you work with problems. And yeah, that is what you get with experience.
Okay. So, if I apply these 10 algorithms that you mentioned on the data, so one of them is going to work, right? It doesn't sound very hard. Just apply all the algorithms you have. One of them gives you the best result. So, why does data science take so much time? Why do you work for 4 months on a single question?
Well, here we are talking about one particular part of data science wherein you're trying to predict something. At the same time, let's say you're given 10 features in a machine learning problem, and these 10 features might not totally explain the customer behavior at all. So sometimes what you have to do is you have to come up with some other feature that helps the algorithm better understand the customer behavior so that your accuracy improves. So one thing could be, so this is where a concept of feature engineering comes very much into play, and people typically spend a lot of time building features so that your model accuracies keep improving over time. So it is not the algorithms that take you to the top, it is actually feature engineering that will push you into the top zones.
Oh, so in a typical data science competition, how much time do you spend for feature engineering and how much time for training your algorithm?
It is typically 50-50 in my case. However, I also know a few competitors who spend almost 70% to 80% of their time doing feature engineering to come up with better features and only use 20% of the time to model. Because if you have better features, you will definitely come up with better accuracy any day. So I currently run a 50-50, but I know people who run it a 70-30. Yeah.
So sometimes, just because of luck, one algorithm is going to perform better than the other because of that little variation in the test data set. Is that possible?
I would probably put it in a very different way. So, the luck factor might actually work out in case of certain competitors when the challenge isn't designed properly or when the data is not split properly. So, let's say in the test data set there are a lot of outliers. Let's say in that case, your model is being trained on historical data that had lesser number of outliers. But if the nature of data is so volatile that it has drastically changed over time, and your test set has dramatically different heterogeneous structure to it, then sometimes the models that we build cannot really generalize, and sometimes you really cannot model the noise because you haven't seen that pattern in your historical data. Sometimes it becomes very difficult to predict how the pattern would come out to be. So in that case, sometimes there could be a lucky winner, but 95% of the times this is not the case. So competition organizers typically put in a lot of effort to make sure the data is evenly distributed and not too heterogeneous to randomly allow anybody to win. But at the same time, it takes a lot of effort to finish in top 10. But let me tell you, it takes a whole different level of effort to actually win a competition.
So the number one, number two, is it because of luck? The difference between number one and number 10, how much of it is luck and how much of it is using the right algorithm and using the right feature engineering?
So I think the top three or top four most often have good features. Some of them being really good features that might not be available with the remaining people. They might not have even thought about it. But typically, the differences in scores are quite low between the very top competitors, unless some competitor just thrashes everybody else because he's found something that nobody else found. So typically the scores are quite close. But having said that, feature engineering would take you a long way. So typically top competitors arrive at features because they believe that features give you a lot of gain in predictive power.
So do you need a lot of computation power for running these machine learning algorithms? Can you run them on your laptop?
Well, I use my 8 GB RAM MacBook Pro for a lot of work that I do. However, when I have to deal with large datasets of, let's say, of size 15 GB or 20 GB, I typically tend to use Google Cloud, the cloud platform. And I find Google Cloud better in the way it is designed and also cheaper than Amazon Web Services. So my personal preference is with Google Cloud. So I tend to use it whenever I need additional computation power.
Okay. So how much do you pay for Google Cloud?
Well, in a typical competition, let's say if I'm spending around 3 hours of my time every day on a particular competition on Google Cloud, and let's say I rent a machine of size, let's say around 60 GB RAM and around 16 core processor, I would probably spend around $30 in a month. Yeah, which is quite decent, I would say. In fact, it also varies because I typically do not spend around 6-7 hours. So whenever I spend 2 hours every day, and if I rent a machine of, let's say, 100 GB RAM and 32 core processor, I am still spending around $25. So that is still fine, I would say, because you're getting the additional computation power, which is helpful.
I would like to hear some of your interesting data science experiences while you were participating in the competitions.
There's this very interesting thing that happened in one competition on Kaggle. So there was this competition on Kaggle called Trade Shift Text Classification, when it was a 60-day grueling competition, and on the last day, just 3 hours before the competition ended, there was something dramatic that happened. So what happened was the top two were fighting neck to neck, and the difference in scores was at the seventh decimal between both of them.
Wow.
And 2 hours before the competition ended, guess what the second ranked team did? They made a submission, and that submission scored exactly the same as the first team score up to the seventh decimal. And there was a lot of drama at the end, and people were waiting to see who would win. But the team that was first before made another submission and just improved the score by seventh decimal. And I think after 1 hour, they actually won the competition. So that was a terrific moment for all of us, and we just couldn't see. We were like, okay, this is a nail biter, man. We have no idea who would win. Let's see who wins in those last moments. So that was one. At the same time, another very interesting experience that I had was when I was with housing previously. One of my projects was on understanding how different attributes of a particular apartment vary with the time that an apartment takes to get rented out in the market. So one of the interesting findings that came out was that in Hyderabad, east-facing houses typically get sold quickly than the other houses. So we came to the conclusion that the people in Hyderabad typically take Vastu very seriously, and they actually follow astrology and all of those. And imagine, only data could have proved this or confirmed this hypothesis. And this is a very interesting phenomenon, in fact. And also the fact that hadn't we collected the house facing data of every apartment during our data collection phase, we would have never come up with this insight, because we would have never had the data in the first place. So this also taught us a very interesting that data collection process is also extremely crucial, so that your processes and your algorithms get much smarter as you move forward in your data science journey.
So we have a few listeners who are listening to you right now, and they're like, where do I start? How do I learn data science? I know nothing about data science. What do I do now? What would you say to them?
Haha, yeah. So this is a very common question that I get almost every week now. So, well, I've probably spoken about this to many people, but I would just tell 2 points that I believe really work. So one is, if you would want to, if you're a beginner and if you would like to start venturing into data science and learn how to analyze data and all of this, you should probably uh, start working on data and learning the tools to deal with data. So I would recommend actually going to www.datacamp.com, and there are a lot of courses on R and Python which are typically used in many companies across the world for analyzing data. So if there is one gift I would probably give to any beginner in data science at the moment, it would be the $60 subscription, the Black Friday deal that is currently going on in US. So it is a $300 subscription that you get for $60, which I believe is a fantastic investment in yourself. So I would say go enroll, take up the courses and learn the tools used to analyze data. And as you start getting comfortable, then move on to www.kaggle.com and start working on Kaggle datasets. Take up a dataset, start exploring data and find any insights which you believe are interesting and share it in the community. And also go through the community's work. So the new Kaggle has introduced something new called kernels, wherein anybody can come enroll themselves for free, have access to data, start analyzing it, post your analysis on the forum and let people comment and take feedback. So I believe they have a concept called newsfeed, the Kaggle newsfeed, wherein you can see all the interesting analysis, all the forum posts, all the comments on interesting analysis being done. So I strongly believe that the newsfeed on Kaggle is way more meaningful than the Facebook newsfeed that I see every day. So for beginners, treat that as your Bible. Go to Data Camp, register, take up the courses, go to Kaggle, start working on datasets, publish, learn, take feedback, iterate, improve. Take this as your Bible, go all in for 6 months, and I'm sure you will actually get to a very, very good phase. And these two plays are seriously sufficient for any beginner to start developing an analytical bent of mind to do data science and start learning the tips and tricks of the trade and building machine learning models and getting really good at it.
The offer that you buy the course for $90, is it only for 1 week or is it $90 all along the year?
No. It's only for the Black Friday deal that is currently. So this Thanksgiving in US right now, right? Yeah, so yeah. The offer expires in 4 days. So yeah.
Oh, I'm afraid the podcast won't be out by then. I'll be traveling, so I'll try to do that, but I'm not sure. Okay.
But probably what people can do is they can still get access to some of the free courses out there. And if they're interested, they can take up one course one by one and start learning things. And as they get along the way, if they're interested, they can probably take up the other courses. So that is one way of doing it.
Yeah, I think that makes sense too. So, were you doing just as well from the first competition that you started?
Oh, no.
How? No? Okay.
Absolutely no, in fact. So I was pretty bad when I started off. But I think it has taken significant amount of time and effort to learn the tricks of the trade. So, and I strongly believe there's no end to learning. You just learn a new thing every day. So, with every challenge and every dataset I solve, I try to learn something new. However, I believe that with the kind of data science content out there on internet today, I think for a person who is seriously committed to learning this, I think it shouldn't take more than 1 year to really do well on various data science problems, on competitions or in your organization, wherever it is. Because when I started off, I think there were only 3 courses on Coursera: computing for data analysis, R programming, and I think exploring and cleaning data. These were the only 3 courses on Coursera, nothing else, and there was no other online content. And slowly, I think now there is a deluge of content. Now you spoil the choice. Yeah, so I think it is a good problem to have, in fact.
Great. So, how much does your Kaggle profile help you increase your reputation as a data scientist?
Kaggle helps me connect with a very focused group of individuals who are keen on identifying patterns, micro patterns in datasets, and also who are experts in machine learning space. and it also helps me make great friendships along the way. So the awesome flatmate that I spoke to you about is a top Kaggler. He's, I think, India's number 4 Kaggler.
Wow.
He's a number 4 data scientist in India. So I've made some great friendships along the way. And also, due to the nature of competitions, participants typically tend to use cutting edge tools and ideas from very, very recent research papers in machine learning and artificial intelligence. And thus, I get exposed to very new ideas almost every week. It also helps in achieving a comprehensive understanding of the field and also cutting edge things, what and how where the field is going and what you would want to learn to keep yourself always in advantage ahead of your peers. And also gives me a very, very good hands-on skill, be very hands-on, which is a very much needed skill for data scientists. So you should be extremely hands-on. You have to be able to dive into data, see what's there, see, capture signal, ignore noise, and all of those. So Kaggle essentially gives the platform to practice all this stuff. And if you're required to find a needle in a haystack, if you practice enough, I think you have better odds of doing well tomorrow. So, and also there have been a good number of success stories of Kagglers who have secured amazing jobs by working on just Kaggle challenges. So one such person is the guy who used Kaggle as a platform to experiment with his machine learning knowledge, and he went on to win a couple of competitions, and then and he's one of the machine learning engineer at Google DeepMind, which actually built the AlphaGo AI bot, which beat Lee Sedol, the Go world champion, recently around 10 months ago.
Yeah.
So he's getting to work on cutting edge AI stuff, and he started on Kaggle. So Kagglers also have a very good reputation in the industrial market. Yeah.
So, do the top Kagglers share their code online?
Absolutely, I think I missed that point. So one of the most wonderful things on Kaggle is that people are very, very open to sharing. So I think the AI community in itself is extremely thriving because of the fact that people are open to sharing. So even if Google comes up with an extremely cutting edge algorithm, they share it the very next day so that the community progresses as fast as possible, and everybody contributes to it, and people actually believe in crowdsourcing in AI. So this particular phenomenon is also seen on Kaggle, wherein top competitors typically share their solutions and thus increase the bar for themselves. So the top Kagglers are insanely good just because of the fact that they always share their solutions and still manage to be at the top, which is very, very difficult in fact to do in practice.
So, can people use Windows laptops for the competitions?
Yeah, absolutely, they can, but I would suggest them not to. Probably
Okay.
go with Linux or Mac, which is so because of the fact that we also use a lot of standalone open source libraries for which we get source files, and we typically tend to compile them and run them through terminal. Well, you can also do them on Windows machines. But I would strictly advise people to start with Linux or OS Mac platform, and probably move on to Windows if they are really comfortable with the whole ecosystem.
Yeah, I think that makes sense. So, is there anything else you would like to share?
Uh, I believe that data science is one of the fastest moving industries currently, and people who are interested in mathematics or who are fairly experienced with programming should actually go through it. And if they find it interesting, they might as well want to jump onto the bandwagon. And it is here to stay for a very long time. And it's also a very interesting field just because of the fact that data science can be applied to any industry. So essentially it's about mathematics and statistics. So there is no industry where statistics cannot be applied, right? So even data science is one such industry. You can pretty much apply it anywhere. So the leverage that data scientists have is they work as a horizontal. Today I might be interested in a payments industry. Tomorrow I can be interested in ad tech industry. Probably day after tomorrow I might work with the gaming industry. I do not know. But the very fact that you have a very strong statistical foundation helps you thrive across multiple industries, which is a very, very massive advantage over people who have specialized skill set in one particular industry. So I believe data science is interesting, very exciting, and probably the right place to be in 2016 and moving forward.
Thanks, Phani. It's been great talking to you. You have been very generous with your time.
Well, thank you, Surya, for actually hosting this, and I'll be very happy if even if one or two people take out positives and actually succeed in their own data science journeys.
Yeah, do you have links where people can follow your work?
Yeah, definitely. So I typically host my projects on GitHub. So at the same time, I also write blogs on Medium. So my name is Phani Srikanth, PHANISRAKNTH. You can go to LinkedIn, linkedin.com/in/slash Phani Srikanth, and I have all my projects put up there. I have all my GitHub links put up there. I have all my blog posts put up there, the links. So you can pretty much navigate through all of these mediums. And if you have any questions, you can probably reach out to me on LinkedIn, or you can just post on GitHub. If you have any questions, you can raise an issue, or you can probably comment on my blogs, or you can probably just text me on Facebook. So I think I am pretty accessible on that end.
Great. Thanks, Funny. It was really nice having you on the podcast.
Thank you, Surya, for having me. It's been a great pleasure talking to you as well.